Yes, sir. That's why we have to have a pineapple on the pizza every time. Exactly.
All right, hello, 606. So let's get started. So today we're going to be going over smart contracts and token standards. Yeah, so basically the main things that drive Web3, they're the core of decentralized apps and also creating tokens on networks such as Ethereum. So if you haven't already, scan the QR code, please, because we need to take care of attendance. Oh, I should do that too. I haven't done that. Go, Thomas. My advice is coffee on site. All right, does anyone still need to? All right, I'll wait a little bit. Okay, right, good to go on. All right, cool. All right, so let's start off with the definition of smart contracts. I just ripped this from Wikipedia. A smart contract is a computer program or a transaction protocol which is intended to automatically execute, control, or document legally relevant events and actions according to the terms of a contract or an agreement. And so basically what that means is that smart contract is a program where the code kind of represents a contract, kind of like saying how a deal will happen if executed. And so more specifically in what we're looking at here is we're going to be focusing on Ethereum smart contracts. So it's a smart contract in Ethereum would just be compiled code that lives on the blockchain. And so that has some implications such as it being immutable. So basically you can't change the smart contract once it's on the blockchain. It's transparent. Anyone can see the bytecode and can decompile it and basically figure out what the code is, or if you're the developer, you can upload the code and anyone can compile the code and then compare it to what's on the blockchain and verify the code. And it's also accessible to anyone because of how public the blockchain is and the decentralization, everything like that. And then also the computation is done on the client side, given the code that's stored on the blockchain. Many people, I don't know about many, but some people get kind of confused when Ethereum is compared to like a decentralized computer. Like the network itself is not really doing computations. The computation is done by the miners on their local computer, and then the result of the program being executed is then submitted into a transaction pretty much. So one important thing when talking about smart contracts is the Ethereum virtual machine, also known as EVM. And so basically, this is where all nodes or miners run the Ethereum blockchain. So it kind of takes all the data that's sent to them and computes the state of the Ethereum blockchain. So every block has transactions, and those transactions show like transfers from like one account to another. And then when you add up all of the blocks in the blockchain, you come up with a result or a state where each account has X amount of tokens and such. And so the EVM can execute compiled Solidity code. So Solidity is a language that Ethereum smart contracts are programmed in. And so smart contracts in Ethereum are Turing complete, which means anything can be programmed really. I put a link by Turing complete if you guys want to like look more into that. The slides will be posted on Discord later. And so if you're having trouble or if you're a computer science student and you're familiar with Java, it might help to compare this to the JVM, the Java virtual machine. So every time you code something in Java, you compile it to bytecode, and then the JVM runs it. And then that's how basically you run Java programs. And so it's just like that. Solidity, you compile it to bytecode, and then the bytecode is run in the EVM. And so EVM is the most widely used smart contract system or infrastructure, whatever you want to call it. So EVM compatible chains are very common. And so basically they're basically chains that behave really similarly to Ethereum. And so some names that you might have heard are Binance Smart Chain, the Avalanche C Chain, Harmony, Phantom Opera, etc. And you may be wondering about other chains such as Solana. And Solana is an example of a blockchain that does not use EVM. They have their own system where smart contracts are coded in Rust, for example. I think you can use other languages, but Rust is very popular for that one. And then there are other blockchains such as Cosmos or Polkadot, where they have basically different subchains. And on these kinds of networks, you can create a subchain that's EVM compatible. For example, the EVMMOS chain on Cosmos. Any questions about EVM or smart contracts so far? All right. So to understand a smart contract, we can kind of look into the life cycle of like the hands-on experience when you're developing a smart contract and everything that happens with this. So first, the developer will code in Solidity, create a smart contract that does something. Doesn't really matter what, but they'll compile the code into bytecode. And so basically that's just more computer readable code, has kind of like lists all the operations in order for the computer to run. And then they'll take this bytecode, which is like a very long string of legible letters and numbers, and they will put that into a transaction and send it on Ethereum in a contract creation transaction. And I'll show that in a second. And so the contract creation transaction is then included in a block as a miner mines it, and then it's added to the chain. And so this block is where the program is located. And so the code lives inside of the transaction. And so that's kind of where you will find the program. And so let's say a user wants to use a smart contract, they want to interact with this. So they call a function from a smart contract, and basically they'll submit a transaction with the function call and the parameters in the input data of the transaction. And so a miner will see this transaction and they're going to include it in a block. And so they need to compute the result of the transaction and the input data given. So they execute the function call in the EVM, they'll get the result, and then the miner will include this transaction in a block and then add that block to the blockchain. And then the function call is pretty much complete. And yeah, any questions about that process? Okay, so let's take a look at an example of a smart contract. Recently some of us went to New York for a hackathon, and so this is I'm going to show some code of my project. All of this stuff is just library code, but like here's like the core code in the bottom. Solidity is a pretty simple language. It's not too hard given programming experience. And so what else can we look at? So this code is then compiled into this contract creation code. So this is what the bytecode looks like. It's very illegible to humans. And so this contract was deployed onto the Ethereum testnet here. In this contract creation transaction, so you can see that it was from my address and then to, and then the contract's address, and it says contract created. And then if you click see more, you can see that input data has just the bytecode of the contract there. And then if we want to look at a transaction where a user interacts with the smart contract, we can go in here. So I have a function in the smart contract called lock, and you can kind of see that if you look right here, it says lock. So let's go into that transaction. You can see this was me again, interacting with the smart contract. So interacted with the smart contract and then go into the see more, and then you'll see that in the input data, there's a function that I called lock, and then there's some parameters to it, and then I passed in some numbers and such into the parameters. And Etherscan has some tools to make it more understandable. So any questions about transactions or deploying smart contracts? Yes, Wyatt.
Does it cost money then to put a contract out there even if it never gets executed?
Yeah, so in the smart contract creation, you can see that there was a transaction fee associated with this. So Ropsten is a test net, so it has very low fees. And so the gas price is really low. And I did a calculation where I took like a Ethereum mainnet gas price, which is much larger than this, and I multiplied it by the gas usage, and I got like whatever is equivalent to like $300. I think it was like 0.1 ETH. So it's pretty expensive to deploy a smart contract. Yes, Matthew?
I'll like bring out MetaMask and show them like the public address, like explain what that is, and like how you said like from this like huge hexadecimal number, right? What that exactly is, and like MetaMask.
Wait, what do you want me to show in MetaMask? I can probably just show it in Etherscan, but you want me to show like the address of the contract? Okay, so here we have the contract, and so each contract, when it's deployed, it basically it's kind of the equivalent to an account. It kind of can act like an account, just like a normal Ethereum user. So it's given an address, and so when you want to interact with it, you're basically sending a transaction from you to this address, and then within the input data, you're kind of calling functions that are within the smart contract. Is that kind of what you're saying, Matthew? Yeah. So basically, yeah, any contract calls, the destination address will be to the smart contract. Moving on. So next up, we have token standards. So basically, ERC20 tokens are any token that's on Ethereum that isn't ETH. So we have like things like Tether, USDT, Chainlink, Shiba Inu, Uniswap governance token, Maker token, Wrapped Bitcoin, etc. And so basically these tokens are made by basically just an agreed upon standard of smart contract structure. So when there's a standard, basically anyone can kind of call the same functions and expect it to have a certain kind of behavior. Let me hide this really quick. So in a ERC20 smart contract, we have a mapping of addresses to balances. So it's basically storing which address has how many of this token. There's a mapping from address to mapping of address to amount. So it kind of, an allowance is basically saying that this address can spend X amount of my tokens. So that's kind of important when you're interacting with a smart contract and you want to let the contract kind of move around your tokens. So you have to approve the contract to access your tokens. And so there's a total supply variable that just tracks the total supply of the token. So in smart contracts, you kind of want to have some of these like tracking variables sometimes because it's very computationally expensive to go through all of the addresses in the balances map and add up the balances to get the total supply. So in different functions that kind of modify the total supply, it'll just increment or decrement the variable. And so there's also strings that represent the name and symbol of the token. And so basically like Shiba Inu will be like SHIB, for example, and then for the symbol, and then the name is obviously Shiba Inu. And so that's kind of how you can know which token you're interacting with, besides looking at its address. And so there are like public functions for reading all that information. And then there's also functions that modify the balance, allowance, or total supply. So we have like transfer functions, so like transfer from this address to this address with this amount, and it'll basically just modify the balances map and say that this address has this new amount, and then this address has this new amount. And so mint and burn will obviously change the total supply value and also mess with the balances as well. So an example, like I just said, transferring X amount of tokens from me to you. So what the transfer function does is it first gets my balance of tokens. So it calls the balances map, says I want to get how many tokens Brian has with his address. And then so if my balance is greater than or equal to X, then we can go ahead with this transaction and we can subtract X from my balance and then add X to your balance. So just do balance, let's say like Matthew equals Matthew's balance plus X, and then my balance is my balance minus X. And so now Matthew has received X amount of tokens. So you've probably heard of NFTs. And so NFTs are also follow a token standard called the ERC 721 token standard. And so examples of non-fungible tokens like Bored Ape Yacht Club, Uniswap V3 positions, stuff like that. I would say CryptoPunks, but CryptoPunks has two different versions. One's an ERC 20 version and the other is ERC 721, because CryptoPunks were actually created before the ERC 721 standard. So it's kind of an interesting thing if you want to look into that. And so basically one ERC 721 smart contract holds a set of unique tokens. So like, let's say there's a collection of NFTs. It's going to be all under one smart contract. It's not going to have one smart contract per NFT because that's very like expensive for one, and it's just very complicated. So it's kind of similar to ERC 20. So except tokens in ERC 721 will have specific IDs, and then they don't have like amounts, so they're not divisible. So in a ERC 721 smart contract, there's going to be a mapping of owners, so from token ID to who owns it, so the owner address. There's also a balances map that's more for just like just good to know info. It's not necessarily needed, but it maps an owner address to a token count to see how many of NFTs in this collection that a person has. And then there's also a map for token approvals. Like I was saying before, you have to approve a smart contract to give a smart contract permission to your tokens in order for it to move it first. And so it does have similar functionality to ERC 20 tokens in terms of transferring, minting, approving, and all those kinds of functions. But a unique function that is introduced in ERC 721 tokens is the token URI function. And so basically that returns a string, and in that string is often the token's unique metadata or a URI for the location of the data. So first we can look at one where the URI or the token URI is actually like a URI, and that would be in Pudgy Penguins, for example. So I'm on the Pudgy Penguins smart contract. And so they have a bunch of functions here, and one of them is token URI. And so I'm going to pass in token ID 1, for example, query it, and it's going to come back with a string that has a URL. So if we go to this URL, we're given a JSON file, and you can kind of see like the attributes to this particular penguin. And then it also has the image within the data. So if we go to that image, you can see that the penguin that belongs to that specific token. So that's basically how NFTs can hold data and kind of reference an image. So yeah, that's the first Pudgy Penguin. And then another example of NFTs and token URI is Uniswap v3 positions. So this is a Uniswap v3 positions NFT smart contract. And so basically Uniswap v3, because it's concentrated liquidity, each position in the liquidity pool is unique. So they, instead of giving like ERC20 LP tokens, you're going to get an NFT that represents your position. And instead of using something like IPFS, which Pudgy Penguins use, as you can see here, they use IPFS to host the file. Uniswap just puts all the data on the blockchain. Pretty expensive, but it is what it is. And so if you look here, you can see that the string is a JSON encoded in base 64. So if we decode that, put that here, you can get the result, the JSON result here. And then within this JSON thing, you can also see there's a field called image. And if you like copy and paste that into a tab, you can see the image that is associated with this NFT. So that's pretty cool. You can see that this particular NFT is a Uniswap and wrapped ETH pool. Any questions? NFTs. All right. So another standard, this is a newer standard. It's kind of a combination of ERC20 and ERC 721. It's called ERC 1155. And so this smart contract is capable of holding both fungible and non-fungible tokens. And so basically how this works is each type of token has an ID and a supply. So let's say I have a 1155 contract and I mint a token with ID 1. If the supply of that token is only 1, then it's non-fungible. It's just a unique token. But if I mint a token type of 1 or another type of token, and then I give it a supply of greater than 1, obviously it's not unique. It's going to be a fungible token. And so it's basically just a smart contract that holds both NFTs and fungible tokens. And then the token type is just given an ID to kind of separate them. So the contract structure is pretty similar as what we were seeing before. We have a balances map. So this one, it maps token IDs to a mapping of address to balances. So if you take token ID 1, you'll get a map of all the addresses that have or that own this token ID, and then you'll see their balance. So basically same functionality, transfer, mint, burn, approve, etc. And then it also has a URI function, just like ERC 721, which can be called for any token ID, basically the same way that ERC 721 token URI function works. But this can be called for any type of token, whether it's fungible or not. So you can give a URI to a fungible token if you feel like it. And so another unique part of this standard is that it can deal with multiple tokens at once in a single batch function. So this contract is gas efficient. It was kind of designed to kind of help out with gas costs and reduce that. So an example, when I was, so the hackathon project I was referencing earlier uses the ERC 1155 standard. And so when I was trying to learn about it, I found an example of a type of ERC 1155 token. So it's called MALPETS. I think MAL stands for like Moon Ape Lab or something, but it's just some random project that I found. And so if you look in the inventory, they have a bunch of different like NFT looking things, but you may notice that there are tokens that look the same. And so these are different tokens, but they have the same token ID. So basically, this is a fungible token within the smart contract. So token ID 1, you can see all the info about it, but so if we go into the contract and read the contract, we can get the URI of token type 1. And then, oops. We can take a look at this data. So there it is. Let's look at the image. So yeah, pretty cool. I wonder if this contract holds any like actual NFTs, but I'm not really sure. But yeah, that's one use of an ERC 1155 contract. Basically, this project has a bunch of different types of pets, but they're not totally unique, but there's like different sets within it. So yeah, that's pretty cool. Any questions about 1155? Yes, Wyatt?
What happens if someone trades like the big, like ERC 721 token to somewhere else? Or is that not possible?
What do you mean?
Trade the fungible. So you can't sell like the whole asset.
Wait, what do you mean? So basically, ERC 721 is separate from 1155. Basically, I was just saying it's a combination of both like fungible and non-fungible. So within 1155, they have a transfer function, and you can transfer like basically it takes in parameters like the token type and then the amount. And so if you're transferring an FT that's in an 1155 contract, you're just going to transfer like that token ID and then to whoever, and then it just have a amount of 1. Does that answer your question? All right, cool. Yes, Matthew. Yeah, sure. No, you can ask. This is kind of the end of the presentation. All right. Well, so here are the references. Any questions, Matthew?
Oh, okay. So like, like the whole debate about whether NFTs will like, keep up in the future, right? Like,
Mhm.
people what do you feel about NFTs? It's like copy and paste the image of the image that we saw online just now, right? And
Yeah.
What would make it any less valuable than the original image? So like, what are your guys' thoughts on that? Like,
Good discussion question.
like who here is for NFTs? Like, right? Who believes in NFTs? I'm so smart. Do you guys have like any specific reasons why you guys believe in NFTs?
I only believe in specific types of NFTs, but the whole concept of, like, I mean, people have traded things like NFTs for years, like concert tickets and stuff like that. So I think if they use it for concert tickets, it'll be very valuable.
I have a question. So, right, NFTs are like unique property, right?
Mhm.
Was there any way to have a unique property online before NFTs?
Well, yes, I guess. We can take a look at the CryptoPunks ERC20 version. So basically, ERC20 obviously is not the NFT standard, it's the fungible token standard, yet CryptoPunks was able to basically make non-fungible tokens within a ERC20 contract. So let me try to find it really quick. Yeah, so here's the contract. You can see that this is wait, let me see. Is this the right? contract? I think it is. Yeah, so basically, this is an ERC 20 contract. It has a max total supply of 10,000 to represent the 10,000 CryptoPunks. And so within the contract, they have this image hash. So basically, all the CryptoPunks are basically like a square of an image full of 10,000 CryptoPunks, right? And so basically they have that image hash within the smart contract to kind of verify basically to store the image in the contract in like a small way. And then what do we want to look at?
So why is the current NFT better than this?
Because basically, this contract is like a really like roundabout way to kind of assign like a location on the image to like a specific token. I'm trying to find like the functions that kind of like control this, but I can't remember where it is. Oh, punk index to address, right? So basically, I think this contract basically has a map where it has all the like indices, like so 10,000 different entries, and then it maps to which address owns it. So if we want to put in like ID punk index 100, we can see the address of who owns it. And so basically, this is kind of like their way of kind of doing NFTs within an ERC 20 thing. I don't know, it's kind of hard to explain. Do you get what I'm getting at? Anyone confused by this? Because I probably wouldn't be. Yes.
Wait, so the value.
Hmm?
Value.
Value?
Is that determinant on like the owner or like the person who issued it? Like, I know there's like of a board issue that they saw. Right?
I feel like it's a little bit of both, because, well, of course, because like anyone could just distribute it, so like that's a bit of. But then also the owner, because the owner legitimizes the NFT.
Right.
So a lot of times, like the reason why certain NFTs get or get very valuable is because successful NFT flippers look into that project. Oh, if they're buying it, it must be worth something. So I think it's a bit of both. It's collaboration between both sides.
It's kind of counterintuitive, though. That kind of like represents decentralization. Like you have to put your trust into the owner. The whole point of blockchain is like decentralization.
So yeah, like a trend that you could see in a lot of this blockchain application is the decentralization is of the technology, but not of the power on that's built on top of the technology. So like you have wealth that are concentrated very few people's hands, but that is tracked by nodes that are distributed well. So yeah, that's an important difference to keep in mind.
Right. So going by the value of the NFT, most financial assets are valued by their promised return, right?